Okay, welcome back to math class and welcome to chapter 11. Today we're going to be talking about the areas of parallelograms and triangles. Hopefully this is something you're already familiar with and this will be actually pretty easy. So we're going to start off with a parallelogram. Now you may already know this, but the area of a parallelogram can be found using the formula area equals base times height. Now, in a parallelogram, you can pick any side to be the base. Just to keep things straight in my head, I usually pick the bottom one. And the height is not the length of the other side, like it would be in a rectangle or a square. It's the distance from your base to the opposite base at a right angle. The reason being, if instead of putting it randomly in the middle there, if I put it at the corner, still perpendicular, and I took it from this corner, what I'm making are two triangles that are equal to each other. And if I was to pick this triangle up and move it here, then it would be making this a complete rectangle. Hopefully that's clear. Let me erase this one. If I was to cut off the corner of my parallelogram and just pick it up and set it over here, then I would have a rectangle and my base times height would be obvious. So that's where we get that formula from. Your homework will be as simple as you need to figure out the base and the height of each parallelogram, multiply them together to get the area. Unfortunately, the problems won't just always look like, oh look, the base is 5 and the height is 10 and you need to figure it out. But because you guys know so much about triangles, you should be able to still figure things out even if you're not given all of that information. So the example problem we're going to look at is, suppose I had a parallelogram like this. We don't know what our height is, but I've told you that the base is 21 centimeters. I've told you that the side length is 17 centimeters and that this little piece right here is 8 centimeters. Now it's going to be tempting to see a problem like this and think that this side is the height and just multiply these two together and stop. But that's not what you should do, because remember, this is not the height of the parallelogram. The line that's perpendicular to the base is the height. So without knowing what that side is, how do I figure it out? Well, I know that the height is perpendicular to the base, so I know that that's a right angle, which means I know that this triangle that it formed is a right triangle. And what I know about right triangles from all of the chapters before this is that I can use the Pythagorean theorem to find a missing side. So we have a short side, we're missing a short side, and we have the hypotenuse. So remember, our Pythagorean theorem is a squared plus b squared equals c squared. C is the hypotenuse, the longest side. So I'm going to put 17 squared equals b squared, so 8, plus x squared, the number that we don't know. Bring our x squared down. 8 squared is 64. 17 squared is 289. I'm going to subtract 64, subtract 64, and get x squared equals 225. I'm going to take the square root of both sides and get x equals 15. Okay, but I'm not done there. X equals 15. Our x is our height of our parallelogram. So now I can erase that and put 15. So now I know my base is 21 and my height is 15. So I plug it back in to this to find the area. So area equals base times height. Area equals 21 times 15. Area equals 315 centimeters squared. Now the reason I write centimeters squared at the end is because here I had 21 centimeters times 15 centimeters. 21 times 15 is 315 centimeters times centimeters is centimeters squared. That's where that notation comes from. Okay, so that's with a parallelogram. Again, hopefully this is all familiar stuff to you. Next, we're going to talk about finding the area of a triangle. Before I totally erase this parallelogram, one thing that I want you to see about it is that if I took this parallelogram and I drew a diagonal from one corner to the other, what I get, I know my line isn't perfectly straight, what I get is two equal triangles, two congruent triangles. So our area for a triangle, we're still going to do the base times the height, just like we would with a parallelogram, but then we're going to multiply it by half because a triangle is half the area of a quadrilateral. So my area for a triangle equals 1/2 base times height. I still would use my 21 here. That's still the same. And my height is still going to work out to be 15, just like before. But instead of it being this whole area of the parallelogram, it's only this half. Hopefully that makes sense. We're going to use this formula. Primarily, you'll be solving for area and perimeter, but you can also use this formula to solve for missing values. So here's an example like you might see on your homework. I have a triangle. I'm going to say it's 34 inches at its base. I don't know how tall it is, so that's our x, but I do know that its area equals 357 inches squared. One quick thing I want to note before we move on is the height of a triangle has to be an altitude. It has to start at the vertex and go all the way to the base at a right angle. Again, you can choose whichever side you want to be the base, but to find the height, you have to go from the vertex to a 90-degree angle with the base. Okay, so, right, back to this problem. We know our area is 357 inches squared, and we know our base. When they ask us to solve for x, we're solving for the height, right? So we're just going to plug it all into this equation here. Area is 357 equals 1/2 times our base, which is 34, times our height, which is what we don't know, so it's our x. Half of 34 is 17. So we get 357 equals 17x. I'm going to divide by 17, and I'm going to get 21 equals x. Simple as that. Hopefully this is all stuff you've seen before. They might leave this one out. They might give you the height and not give you the base, or they might give you the base and the height and not give you the area, but you should be able to figure out, you just need to find each of these pieces. You guys got this.